Okay, so now we're recording. Okay, so once again, good afternoon, everyone, to our chemistry class. We didn't have a class last week because I was having an exam. Okay, but we're going to continue our today's lesson. So I think if I recall that we haven't done question number 14. So usually this question will serve as a review as well. Okay, so we're going to start. Okay, I'm going to zoom this out first. So for question number 14, so this is like a review of our la 2 weeks lessons. I mean, our lessons 2 weeks ago, since we don't have class last week. So we're talking about ionic equations, and I do hope that you all of you still remember about ionic equations. All right, so the first thing that we probably want to do when we are solving an ionic equation, so I'm going to type it out first. So first of all, we have to sort of separate the compound right here. You're going to separate this. How? Okay, I'm going to write this. I kind of forgot. So we have right here H2SO4. Just going to like mention this instead of the fancy name, just to make this easier. So we have hydrogen here, H2 here, and we're going to split these two to the like simple compound, the simple form. So first of all, this hydrogen right here, we have a two right here, right? So that when you're splitting this, it will become something like this. So it becomes 2H. And since hydrogen is actually like it has its own group, and to become part of the noble gas, which is helium, helium has two electrons. It's two electrons, right? Hold on. Okay. So trying to do this. So this is actually H plus. You can actually see this from the based on the periodic table. I think you can see that. Like the left side of the periodic table, they usually have a positive ions. Well, on the right side, they usually have a negative ions. So this, or should I remember that? So this is plus because we are separating these two. So this is actually a very common one, sulfur monoxide. Say it, sulfur monoxide. So usually it's pretty common. The form is usually the same right here. So this is really sloppy two right here. So this is two, um, this is like -2 ion have a negative charge, and this four right here at the bottom. This is usually the form for sulfur monoxide. And the next one right here. Okay, so usually, okay, hold on. Give me a second. Okay, so give me. Okay, so now we have sodium hydroxide. I almost tempted to say natrium hydroxide doesn't exist as sodium hydroxide, unless it's Indonesian. Since in English we are saying that we say Na as I mean Sodium is not natrium. Natrium is usually like the Latin name. For Indonesian, you can call it natrium as well. Okay, so now we have sodium hydroxide. So once again, we take note that usually the left side of the periodic table are usually positive. They have a positive charge. So usually they're like the alkaline metals, the alkaline earth metals, they have a positive charge, while the halogens, they have a negative charge. This is basically what you need to remember. While the noble gases, they don't have any charge, they are neutral. So that's basically a review. So once again, here. So since we have two right here, at the very front of sodium hydroxide, okay, we're going to write this down. I'm not sure if I have enough space right here. Okay, so we have two right here. We're going to write down. So, okay, that's really messy. Let's write this again. So we have two right here. Um, two. So that means we have natrium, sodium. I'm saying natrium again. Uh, so I think I should just type this out instead of writing it. Okay, so give me a moment. Okay. So I hope this will make my writing better. Okay, so right here we have natrium here. So it become plus. There we go. And this one will be the hydroxide part. So this is will become negative usually if it's only hydrogen, only H. I say that to make it simple. So if it's only H, it is usually a positive charge. Well, if it's OH, like this one right here, so this will become OH. It is just usually a negative charge. Okay. And right here we have, okay, so this is, okay, I'm just making Okay, so yes, this is water, it's confirmed. So we don't have to do anything about it. We can just write it down. Okay, so I don't really have much space right here. I'm supposed to write this on top. Can you just write this down real quick? Okay, so I'm going to delete that. I just going to be write it on top since I don't have much space. Okay. So we can just leave this switch to O. We don't have to split anything because it's just oxygen and hydrogen basically, so we don't have to do anything about it. And now for the last part, right here we have okay, natrium sulfate right here. So we're going to split this. So usually sulfate when we split it is always the same, so we don't really have to think much. It's this right here. It's kind of universal for natrium sulfate when being separated. So we have here, we have the same natrium format here, but since this is natrium we're talking about, we're going to put this in front, so this would become 2 natrium. Don't forget with the positive charge. And then we have the sulfate right here, sulfur monoxide. So it's the same, usually it's the same format. The 2 right here we move right here. Usually it's like that, and the 4 we can keep it, and this 2 right here will move right here. So it's usually like that. Same goes like with this H right here. The 2 goes here, and then the other 2 goes here. Usually it's like that. Okay, so we're gonna put the 4 right here. Okay, so we actually transform this to the ionic form, but this is not the ionic equation. Um, and then how can we transform this to the ionic equation? We need to find that each side, like the left and right side, which have the same element right here. So we can see, so 2H plus, no, we only have the one in the left side, so we can write that down. So we have 2H plus right here. So we have both here sulfur monoxide, so we can cross this out. We also have natrium right here, we can cross this out. So we are left with this. Hey, okay, so I think just wanted to kind of make a revision. So previously I said that this is not going to, I mean, I'm not doing anything to this part right here, the water compound, because it's like hydrogen, oxygen. Well, that part is kind of true for this one right here, but okay, I'm not really good at explaining, but to be honest, yeah, it's kind of that, to be honest, I think I'm not really sure how to explain this. But if you ask me, the one that has like oxygen right here, they kind of like do not separate, as you can see, like from this with the hydrogen right here or with the sulfur, it's still the same. So that's how you can tell. So that's based on what I've actually learned back in high school as well. So here we have it, the um end result, the ionic equation. This part right here. So this is the results. So if you have any questions, just feel free to ask. So I hope that I can like re-explain if you have any questions. Or you can just ask in the chat or ask me directly. So I'm going to erase this first. So I'm not sure if, okay, so we're at 6:15. Okay, so the second one's actually way easier than the first. I'm not sure if, um,
Everything is hard there. I don't even understand all of these A and B's.
which part that you don't understand, I can try re-explain this again. And
A
if you don't,
and B.
um, which one? This question, this two question right here, Mark, is that you're trying.
Yes.
Okay, so I just explained the first question, I mean the A part, but if you don't understand that, okay, I'm going to go to question B. I think question B is actually kind of simpler than the A part. The A part is a little bit complex because yeah, they have like more numbers. So I'm going to explain it again to question B, I think. Since question A, it's yeah, I'm not very good explaining it. I can try to explain question B better. Okay, so this is what we're going to do first. So we have Br right here, which is bromine. So bromine here sits alone, okay? It's a single element, so we don't have to do anything about it. So we can just go straight with writing this. So yes, I do forget
B
about the
R.
yeah, Br. I do forget
What about you?
pardon if there's
What
something that
about
you want.
that two thing? The two small thing.
Which one? The which one? Which one are you referring to?
In B. BR2.
Oh, okay. So this is
Yes.
just I mean the number two, beside Br. Okay, so okay, let me explain. The number beside here, usually it tends to Br2. Okay, how to explain this? Is it to describe or just so that you can tell, I mean identify how many atomic is that? So that's actually Br2 refers to diatomic bromine, meaning that it is diatomic, it's not monatomic. I think that's usually if you say Br bromine, then it's monatomic, but since there's a two right there, then it is diatomic. So that's the difference if you're asking about the small number beside Br. So I hope that answers your question. Okay, and if you have BR right here, so BR2 right here. So should we sometimes see the periodic table as well? So BR is 4 minus it. So BR is part of the halogen. So since it's part of the halogen, so it's part of the halogen is supposed to be active, but I don't think we have to write this down to be honest, because yeah, it's BR2, it's the atomic, we don't have to write anything, so we can just go ahead. So now we have I think calcium iodide. Not calcium, I mean potassium. Sorry. So, okay, so I tend to mix up. I'm sorry if I tend to mix up the Indonesian and English name of the compound, the elements. So, because I was learning chemistry back in high school, it was Indonesian. And when we say the um atomic symbol here of K, we usually call this as kalium, which is sounded like calcium, kalium, kalium. But in English, we call this as potassium. So I kind of like mix this up, so I'm sorry. And natrium, we call this sodium in English, and this K right here, we call that potassium. So just so you know. But in Indonesian, we call this kalium, and this is one natrium. That's it. Okay, so that's intermezzo. There. So we have potassium iodide, not kalium iodide, I'm sorry. Um, so since these are two separate elements right here. So you have to separate them first. So we have here, K, potassium, which is on the left side of the periodic table, meaning that it is going to be a positive charge. So we're going to write this 2K since we have the 2 right here. It's going to be plus. And then we have the iodine right here. Belongs to the halogen group on the right side. Then it's supposed to be negative. I'm going to erase this. So this is 2. So the iodine here. So we're going to put minus right here. Okay. So we're on to the right side now. Okay, so for here, right side we have potassium bromine. So since it has like number 2 right here, indicating that we have 2 of these compound, so it has to be 2 for every elements inside. Okay, so we have once again, here we're going to write this 2, potassium. going to add the positive charge, and then we're going to plus the, so we have two right here. We have bromine again. Okay, so bromine is negative. And then we have here the diatomic iodine right here. So when it's a diatomic, it's not really necessary to write the charges. So you can just go ahead like that. Okay, so now we have transformed compounds to their ionic form. So we are going to find that's actually same. Like, how do you call this? So we're going to, okay, so it's called the spectator ions. I kind of forgot the name of that. So we're going to cancel the spectator ions, meaning that the ions that are present on both left and the right side. So right here we see that this bromine right here, okay, no, I don't right here, so no. So the one that we call the spectral ions here is this potassium right here. So we can cross those two out. So now we're going to write the um new ionic equation that we have here. So we get bromine, your iodide. So that would be, this is the um reactants, and this is going to be the product. Two B R tips. Okay, so this would be the ionic compound. So do any of you have any questions about this? Or if there's something that you would like to ask, you can just ask right away. I tr will try to re-explain this again.
No.
Okay, so if you have no questions, but if suddenly wanna um you think of a question, then it's okay. We can go back to this question again if you suddenly have a question in mind. Okay, I think we actually discussed about this already in the previous lessons. Now we're going to go to question number 15. So this is like a review of previous classes. So we're going to write the ionic equation. So this is about ionic equations again. So I think ionic equations back in high school, I can say it's actually pretty common that one of the very first lessons of chemistry that you will encounter. Okay, so I think we're just going to discuss one of them. So I'm going to choose question number A. Unless there's something that's you find confusing, then I will discuss question B. But if not, we're just going to question A since we all have materials to catch up. Okay. So we have here copper sulfate, natrium hydroxide, is copper sulfate, copper hydroxide, natrium sulfate. Okay. Did I just say natrium sulfate again? It's sodium sulfate. I'm sorry. Okay, so here we have copper sulfate. So I'm going to check where does copper belong. So usually for at the periodic table, usually I'm not sure if every periodic table has that, but my periodic table that I have here is from a book. Usually written like what kind of ions that certain atoms have, like the certain element has. It will be written right there. The element. And for here, copper, we have a plus one or plus two, meaning that it is always a positive charge. So we have this copper sulfate, right? Copper sulfate. Okay, so copper sulfate. Wait, here's the sulfate. We have here's sulfate. Okay, so copper sulfate. So copper sulfate means that it will have two positive ion, so that will become copper two plus. Okay, sorry about that. Two plus, and this is the sulfate part. So the sulfate part is usually the universal. Okay, after that, I think I supposed to write this. I mean, the equations on top, not right here again. Okay, anyway, so we have right here sodium hydroxide. I'm going to add here. So sodium, it's a positive charge, so we don't get positive charge. And then here we have the hydroxide. Hydroxide is usually negative charge. Okay, I almost forgot to add the two right here since you have two of this compound is, I mean, and this whole equation has two of this sodium hydroxide. So please don't forget to write the two or whatever number it has at the very front of the compound, meaning that all elements should follow the number at the front. I mean, in the front number here. Okay, this is now we're going to write about the product. So this is solid, right? Okay, so we just can leave this be. Okay, should I write this down? So just put this right here. Okay, so just to save some space. So this is natrium sulfate right here. We have this again, so Na plus, and this is sulfate. Okay, so now we have all the elements in their ion form. I'm not sure you can say that. It's like the ion form. Okay, so now we're going to find the spectator ions, the ions that present on both the left and right side of the equation. So here we have copper. No, it doesn't have any we don't have any copper in the right side or the product side. So we're gonna see this. So now we have sulfate right here on the left side, but we also have sulfur on the right side. We're going to cross this out. I also have sodium right here on the left. We also have that on the right, so we cross that out as well. So leaving us with copper, and then we have this hydrogen oxide. We have this hydroxide right here. So we're going, this is the product. So the product is still the same. It doesn't change. We have copper hydroxide. So here, so this is a solid form. So basically, we're just trying to simplify this equation. So just say that copper plus hydroxide would be equal to copper hydroxide. And we can just like remove the rest of this. It doesn't really matter to be honest. Yeah, so that's why we're eliminating this. Okay, so technically just by elimination is like this, and then this. So we get this result. Okay, so this is the ionic equation. So if you have any questions, just ask me or if you need re-explanation.
No?
Okay, so if you have none questions, then I can move on to the next part.
Yes, we can go on.
So I think that's enough of ionic equations since we already discussed three questions. I'm not going to do the last part. So it's actually the same method like the previous one. We just like separate, to make the ionic, like determine the ions of each compound and then basically find the spectator ions, and then there you have the ionic equation. Okay. So I think this is the last part of this chapter, not sure. Okay. So solutions and concentrations. So calculating the concentration of a solution. So the concentration of solution is the amount of the solvent and solvent to make one cubic decimeter of solution. Solvent is usually water. There are 1,000 cubic centimeter. Okay, so I'm actually not sure. I think I've actually reviewed about this. I mean, oh my God. I explained about this 2 weeks ago, but I'm just going to have a short review about this before we are going to move on to the sample questions. So compost dissolves to make a cube decimeter of solution. Constitution small decimeter cube right here. Okay, so this is the concentration. The formula is the formula would be number of moles of solute divided by the formed solution that would be equals to the concentration. So we should have to remember the unit. So in chemistry, in this concentration part, the unit would be decimeter cube decimeter right here. It's not centimeter cube, it's decimeter cube. So we always have to change the unit before doing anything else. Like going to the dividing part right here where we need to use the following. Yeah, we need to convert that first. So we do not miscalculate. Okay. So here's a sample question. So we're going to calculate the concentration of sodium hydroxide if 250 centimeter cube of solution contains 2 grams of sodium hydroxide. Okay, so first of all, we usually have to find the AR value, but this time right here we have to determine this. So usually the molar mass or the MR value. So this is they provide the MR value already, so we don't have to find it again. Okay, so how to change to convert to mole? So it's usually the mass, usually here, the mass is 2 grams. We divide it by the mole mass MR here. So 2 divided by 40, here you have it 0.050 mole. So we're going to change that. Not this one. This one right here is already the mole. We don't have to do anything again. Um, right here, this is the volume. It's still in centimeter cube. We need to convert that to decimeter cube. And how do we convert that? We are going to divide this right here, the centimeter cube, by 1,000. So that's the formula. And this is the result. It's 0.25. Okay, so I think someone raised their hands, and if you have any questions, just
Uh, so, how do we calculate the concentration?
okay, so how do we calculate the concentration? You mean how do we find 250? I'm not really sure. Okay, usually the concentration, okay, hold on. So usually we need to do this step by step. So we first of all, we know that the formula for concentration is number of moles and the volume will be divided by the volume. So before we going to calculate the concentration, we need to find the moles first. That's why we do some conversion right here from the mass, usually from here, mass right here, 2 grams, should be divided by the molar mass, so the molar value, the MR we say right here. So there we get the mole. And then after we find the mole, we need to find the volume. So the volume, usually the questions will already state the volume already, but usually they will state this in centimeter cube instead of decimeter cube. And that's why we need to convert that. And why do we need to convert that? Because the end result, usually the concentration will be stated in mole decimeter, it's just like negative cube. I'm not sure how you pronounce that, but it's negative cube right there. So that's why we need to convert the centimeter cube to the cube decimeter. Okay, so after we convert that, like I said before, we divide that by 1,000. We get 0.25 as a result. And after we get the mole and the volume, we can find the concentration. And how do we find the concentration? We see that here we have, so this is mole, we have moles, right? Divided by the volume. So moles right here, we have 0.050. We input that, so that's why I have 0.050. We're going to divide that by the volume, which is 0.25. Here we have it. So 0.050 divided by 0.25, we get 0.20 concentration. So this is the unit. So usually units are pretty important when we're doing questions like this. So be sure to remember that this is the unit for concentration. So is there any other questions that you would like to ask me? I can try by explaining it again.
How could the answer is will 0.20 mole dm negative?
Okay, so why is it -3? Well, this is not negative, right? Is that what you're trying to refer? So, okay, I'm going to zoom this out. Hold on. So this is, okay, so this is usually mathematics that you probably learn in middle school, I think. Okay, so when, um, okay, I suddenly forgot. So just going to say this in like the Indonesian form. So usually the power, oh yeah, the power of, or you can say in Indonesian, you say pangkat tiga right here. So usually, it's the fraction right here. We have the, I think this is like, we call the denominator, right? Okay, so this is the numerator and this is the denominator. So it's not when a power right here, it's in like below a fraction, then when it goes up, and since because you like divide these two numbers, so it's technically this number below goes up. So when a root goes up, this tree right here, it will becomes a negative. So that's usually how it will end up negative. Is that what you're asking? If I get it wrong, you can try and correct me. What was your question?
No.
Okay, so I hope that answers your question though. So that's how you technically find the concentration, and usually yes, you can bring a calculator along, so you can just calculate which makes it more easier. But yeah, that's how we have a negative power right here. It's because it's like below a fraction, so when it goes up, it will become a negative. So I hope that explains it. Okay. So you also need to calculate the mass of a substance present in solution of no concentration volume. So first rearrange the concentration equation to numbers moles. This is small, the unit is small. So concentration times volume is how we find number of moles. So yeah, this is basically we're just the same formula, we're just trying to switch places. So to multiply the moles of a solid by smaller mass. So to find the mass, we the mole number of moles will be times by molar mass, and that's how we find the mass of the solute. So we're just like switching the places. Okay. So this is number 19. Work example. So calculate the mass of anhydrous copper sulfate. Okay, so it doesn't really matter to be honest. The name, it's really hard to pronounce. In 55 centimeter cube. So once again, we need to take note that still in centimeters cube. We need to convert that to the centimeters cube and of a 0.20 mole. Okay, so now we already know the concentration. Now what we're trying to find? We're trying to find the mass. Okay, so first of all, we need to do something about what we already know. So we already know the volume right here. So we need to change that. 55 will be divided by 1,000. Then we get 0.055 decimeter cube. Okay, I'm sorry, scrolled too far. So okay, so to find the mass, we need to times so to find the mass right here, you can see the formula on top. So it's actually moles times molar mass. So we have to find the mole first since that's like one of the information we haven't found. So how to find the moles? We have to do a little bit of multiplication. So it's from the concentration, we have concentration is 0.20. So 0.20 will be multiplied by the volume association. The volume association here is 0.055. So input the number here. This is the concentration, and this is the volume. So here we have it, okay, 0.011 mole. So now we already find the mole. Okay, so actually to calculate a molar mass is not that difficult. So okay, what is this again? Copper sulfate. Copper sulfate is copper sulfate. So, oh, copper 2 sulfate. Okay. Copper 2 sulfate. Okay, copper 2 sulfate. Okay. So this is the compound will look like. So we have copper right here. Okay, to find the MR value, we usually sum all the AR values of a compound. So we have here copper is 63.5. And then we have sulfur, which is 32.1. And we have four oxygens right here. So four oxygens means that we have to times the AR value of oxygen by 4. So here we have it 4 times 16. Okay, so now after we sum up all these number, we times that by the mole here, which is 0.011. So there we have it 1.8 grams. So this is actually been simplified to two significant figures. So this is the sample question. And do you have any questions about this work sample? So if not, I can move on to the one that we need to work on. Okay, so it's okay if you have no questions because number 16, you probably have questions about it. So we're going to do the first part of the question, and if we have more time, then we can do question B as well. But if not, then we're just going to do the A part, and we can continue B for our next meeting. Okay, so first of all, calculate the concentration. So once again, this is the unit of the following solutions. Okay, so first of all, we need to think first. So we need to find the concentration. So what is the concentration formula? That would be mole divided by volume. So concentration, I'm going to write this down. Concentration would be mole divided by the volume. So this is the equation for concentration. So why am I writing this down? It's just because that just so that we know that what we are trying to looking for. Okay. So So what's the concentration? Okay, so first of all, we need to find the MR first. Molar mass. So MR is of NaOH. So that will be 23. So sodium is 23. Right here, going to plus right here 16. So we have 16, so plus 16, and this is 1. I just 1. So that will be equal to 40. So to find the mole, we have to do this. So mole, where can I write this down? So I'm going to write this down right here. So mole right here. Okay. So we have here 2 grams. So mole is usually mass divided by the molar mass. So we have 2 right here. We're going to divide that by 40. So 2 divided by 40 equals to 0.05. Okay, so now we find the mole already. Okay, so we already told the about the volume already. So I'm going to erase the top part right here. We already find, okay, just erase everything. So let's just say we find the mole already. The mole is 0.05. So this is the mole. So we're going to find the volume here. So the volume would be 50. Since this is in centimeters, we convert this to cube decimeter. So divide that. So we get 0.050. So should we just do this and then 2 zeros at the front? So we get 0.050. And don't forget about the unit. This is a cube decimeter. Okay. So now we already have the mole, we already have the volume. Now all we need to do is calculate the concentration. Okay, so here we have the mole right here is 0.05. And then the volume would be 0.050. Okay, that's 50, right? Okay. So this equals to 1 mole decimeter. Okay, is this the right calculation? Okay, hold on. Let me just take out my calculator again. Oh yeah, it's actually the same. Oh yeah, I forgot. This is actually, you can just actually forget about this 0 right here. And 0.05 divided by 0.05 will be equals to 1. Okay. Okay, so this will be equals to 1. So this is the concentration. So do you have any questions so far about finding concentration?
No.
Okay, so I hope that's all clear, but if you have any questions, yeah, just ask right away. But I should not really worry about this one since we're actually going to talk about concentrations again the next meeting. So you can actually ask about this question again if you have any questions about this part. So we still have 10 minutes. I think we can still do the second part of question A. So I promise it won't take long to do this. Okay. So it's the same. We still need to find the concentration. And once again, I need to write it. So it's actually mole over volume. So this is the equation for concentration. Okay, so first of all, so this is just my way of doing this. So we already know that we should convert the centimeter cube to decimeter cube. So we need to do that first. So the volume here, we're going to convert this to 50 centimeter cube. Going to divide that by 1,000. So we get 0.025, right? Yeah, 0. Okay, hold on a second. I think I got this wrong. Okay, I'm sorry. We don't need an additional zero. I miscalculate. So it's a, oh yes. Okay, so it's supposed to be 0.25 decimeter cube. So define the volume. Now we only need to find the mole. Okay, so I'm going to calculate this first. So that would be 24 plus, okay, sorry about that. Okay, so now we have 16, so that we plus 32. And then we have 4 hydrogens, so that would be 4. Okay, so okay. Okay, so here we're going to calculate the molar mass. So we have carbon right here, so that would be 12 plus, so hydrogen is 1, so this we have 3, so 1 times 3, that will be 3. And then we already have another carbon, so plus 12 again. So we have 2 oxygens right here. Oxygen is 16, so 16 times 2, that would be 32. And we have another hydrogen. So the air of hydrogen is 1, so we get plus 1. So 12 plus 3, that will be 15. 15 times 12 will be 27. And 27 plus 32, that will be 59. And then 59 times 1, that will be 60. So we have 60 grams per mole. It's really a really sloppy handwriting right there. I feel like I need to rewrite this. Okay, so here's the MR value. And we already find the mass right here. It's already stated in the questions, it's 12. So we're going to find the mole by dividing mass over MR value 60. So that would be 0.5, I think it's 0. Okay, sorry, it's not 0.5. Is it? 0.2. Okay, so 0, oh yeah, 0.2 divided by 5. Okay. 0.2 mole. So 12 divided by 60, so we have 0.2 mole. We have the mole, number of moles. So here we already have the volume. So all we need to do is just calculate the concentration. So concentration right here, going to divide it. So we have 0.2. This is small. We're going to divide that by 0.25. 0.25 cube decimeter. So that would be, okay, let me calculate this real quick. So we have 0.8 decimeter cube. It's negative right there. Okay, so now we have it, the concentration 0.8 mole decimeter cube. So we have 5 minutes before our class ends. So do you have any questions about finding the concentration? Or is there anything that you'd like to ask about the previous ones?
No.
Okay. Okay, give me a second. Okay, so since none of you have any questions, but if you have any questions about this again that you probably just think about it, then you can ask us on our next lessons. So I'm going to stop sharing my screen. Guys, stop sharing. Okay. Okay, so since all of you have any questions, I'm going to end this class. Thank you everyone for participating in this class, and I'm hoping to see all of you next for next lessons. So I'm going to stop recording this as well.